Welcome to this explainer. Today, we're going to decode the hidden DNA of algebra. We're taking those mathematical strings of numbers and letters that, let's be honest, can sometimes seem a bit abstract, and we're transforming those dry equations into your ultimate mathematical toolkit. Think of this as getting the master key to a whole new level of problem solving. It's going to be a lot of fun. Now, I want you to imagine for just a second that you are a mathematical detective. What if I told you that you don't always need to do the heavy lifting of fully solving an equation to know exactly how it's going to behave? I mean, can you actually solve a mystery just by looking at a few initial clues? Well, spoiler alert, you absolutely can. And by the end of our time together today, you'll know exactly how to do it. Okay, so here's our roadmap. 1. Anatomy of a quadratic. 2. 3 ways to solve. 3. Predicting the roots. 4. Secret relationships. And 5. JEE level mastery. Let's jump right into Section 1, Anatomy of a Quadratic. Before we can solve anything, we've got to establish the suspect profile for exactly what it is we're hunting. What actually makes a quadratic equation, well, a quadratic equation? Here is the foundational DNA of our equation. ax squared plus bx plus c equals 0. Notice those 3 little letters? A, B, and C? They're just constants, meaning they're just regular numbers. But they hold literally all the secrets to finding our target, which we call the roots, or the zeros. The roots are simply the values of x that make the whole equation perfectly balance out to 0. Oh, and there is one absolutely massive rule here. A cannot equal 0. If a is 0, that squared term just vanishes, and our whole suspect profile changes completely. No way around that. Let's look at this in practice. Notice how the equation x squared minus 5x plus 6 equals 0 fits our profile perfectly. It has that degree of 2, that absolutely crucial little squared symbol. Contrast that with the linear imposter, 3x plus 5 equals 0. No square term means it's just a straight line. It's not a quadratic. Every single quadratic equation has to have that power of 2. Moving right along to Section 2, 3 ways to solve. So now that we know exactly what we're looking at, let's open up our detective's toolkit to crack the equation wide open and actually find those roots. We have a strict hierarchy of tools to find them, depending entirely on what the equation gives us. Step 1 is always trying factorization. It's quick, it's elegant, and if the numbers play nice, you can just group them up, like instantly turning x squared minus 5x plus 6 into x minus 2 times x minus 3. But, when the numbers don't play nice, we move to step 2, completing the square. This is a bit more of a systematic build, where you manipulate both sides of the equation to force a perfect square. It's incredibly clever, but yeah, it takes some work. And when all else fails, we bring in the ultimate weapon, the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Sure, it looks a little intimidating, but it's incredibly powerful. You literally just plug in your constants, a, b, and c, and it forces out the answer every single time, without fail. Whether your roots are simple fractions or just messy, ugly decimals, this master key turns the lock. Which brings us to Section 3, Predicting the Roots. Now, what if I told you we could look into the future of an equation without doing the heavy lifting of fully solving it? The crucial point here is this tiny piece of the formula hiding right under the square root. It's called the discriminant, represented by a capital D, and it equals b squared minus 4ac. Because it sits inside that square root, this little cluster of numbers literally acts as our crystal ball. By calculating just this one small piece, we can instantly know the exact nature of our roots before we do any complex math. The discriminant maps out our possibilities perfectly. If d is greater than 0, meaning it's positive, you're guaranteed to have 2 completely distinct real roots. If d perfectly equals 0, the equation only has one unique answer. It's essentially 2 real roots that are exactly equal to each other. But if d is less than 0, meaning it's a negative number, well, you can't take a standard square root of a negative number. This plunges us right into the realm of complex imaginary roots involving that little letter I. And what's really fascinating is what happens when we do get those complex roots. When you're dealing with real coefficients, imaginary roots never travel alone. They always travel in pairs, called conjugates. Think of them like twin suspects. If you know one root is a plus ib, you automatically, without a doubt, know the other root is a minus ib. If you find one, you've instantly found the other. Okay, let's get into Section 4, the secret relationships. Now for the real magic trick of this explainer, discovering the secret relationships between the roots themselves and those coefficients a, b, and c. These are known as Vieta's relations, and they are incredibly powerful shortcuts. They let the roots communicate directly with A, B, and C, completely bypassing the need to ever calculate the actual roots. If you take your true roots and add them together, their sum, it will always exactly equal negative b divided by a. And if you multiply your two roots together, their product, it will always equal c divided by a. You literally don't need to know what the roots actually are to know their sum and product. How cool is that? And because of Vieta's relations, we can do some amazing reverse engineering. If we merely know the sum and product of the roots, we can instantly rebuild the original equation backward. You just take x squared, subtract the sum of the roots multiplied by x, and add the product of the roots, setting the whole shebang to 0. So if someone tells you the sum is 7 and the product is 10, boom, your equation is perfectly reconstructed as x squared minus 7x plus 10 equals 0. It's honestly like reassembling a whole dinosaur from just 2 bones. Finally, Section 5, JEEL Level Mastery. Let's put our modular toolkit to the test with an advanced JEE level concept check. Imagine this mystery for a second. You have an equation, x squared minus kx plus 16 equals 0. You're entirely missing that middle coefficient, k. It's totally unknown. Yet you miraculously have one clue. You know one of the roots is exactly 4. So how do you find k without doing agonizing pages-long algebra? Well, we use the secret relationships we just learned. Let's break this down systematically. Step 1, we look at the c value, which is 16. Our a is 1, so the product of our roots is 16 divided by 1, which is just 16. If one root is 4, the other root must also be 4, because, well, 4 times 4 is 16. Step 2, we need k, which sits right there in the b position. We know the sum of the roots is negative b over a, which in this case simplifies to just k. Well, if both roots are 4, their sum is exactly 8. Step 3. Applying that sum rule logically reveals that k must be exactly 8. We literally solved it in seconds using pure logic. Now listen closely, because here are the insider secrets and common traps that routinely trip up even the most careful mathematical detectives out there. The biggest mistakes usually aren't from a lack of knowledge, but a lack of precision. Things like forgetting that a absolutely cannot be 0, dropping a negative sign when you're plugging numbers into the quadratic formula, miscalculating the discriminant and thinking complex roots are real or vice versa, or simply mixing up whether the sum formula is c over a or negative b over a. Paying close attention to these traps is exactly what separates a novice from a true expert. To combat those traps, you're going to want to keep these rapid-fire mathematical hacks in your back pocket to save crucial time on complex competitive problems. If a problem says the roots are reciprocals of each other, don't even bother calculating them. Just immediately know that coefficient c must equal coefficient a. If it says the roots are equal, instantly set your discriminant to 0 and solve from there. If the roots have opposite signs, their product must be negative, meaning c divided by a is less than 0. Guys, these are the exact shortcuts that elite test takers use every single day. As we wrap up this explainer, I want you to step back and just look at the bigger picture. We've taken a string of letters and numbers and shown just how predictable, structured, and logical they really are. But the real question is this: how do these simple algebraic DNA strands form the hidden architecture of the universe? I mean, from calculating the trajectory of a rocket in physics to finding maximum optimization in advanced calculus, the quadratic equation is quite literally everywhere. So as you move forward, consider how the master keys we've built today will inevitably unlock even deeper mysteries in your future studies. Keep that detective mindset alive.